You know M of t, right? What is M of t?
Modulating signal.
Modulating signal.
Okay, modulating signal. Any other name for modulating signal?
Message signal.
Baseband signals.
Baseband signal.
Message signal, wonderful. Message, baseband. Fine.
Baseband signal.
Okay. Anything else? Modulating signal, message signal, baseband signal. Anything else?
Audio signal.
Audio. Okay.
Analog signals.
Audio signal. Now, my next question is, what is the frequency range of M of t? You said all these things, right? You said message, audio, baseband. I'm asking what is the frequency of these? No
20
idea?
to 20 kilohertz, sir.
You're
Audio
saying 20,
frequencies.
20 to 20 kilohertz? 20 to 20 kilohertz is the frequency range that we can hear. That is the audible limit. But my question is, whether it is modulating signal or message signal or baseband or audio, these are the signals that we generate with our vocal cord. So whatever we generate from our mouth, whatever I am speaking is my M of t, baseband signal. So out of 20 to 20 kilohertz, we can speak roughly 50 Hz to 3 kilohertz. Of course, some girls or female vocal cord, because they have a little amount of high pitch, they can go up to 3.5 or 3.7 kilohertz. So we generally name it as 0 to 4 kilohertz. So this 0 to 4 kilohertz is called, we call it as band limited baseband signal. The name of M of t is band limited baseband signal. The perfect name of M of t. Okay. Now, what is C of t?
Carrier signal.
Carrier signal.
Carrier signal. Fine. So C of t is carrier. Somebody said carrier. Now, can you define carrier? What exactly the carrier is?
High frequency signal.
So carrier is a high frequency signal. Okay. Forget about frequency. Can you differentiate M of t and C of t? Whether it is high frequency or low frequency, what is the fundamental difference between M of t and C of t. I mean the band limited baseband signal and the carrier. You said all these things: modulating signal, message signal, band limited, and of course carrier is high frequency. Just tell me the fundamental difference between M of t and C of t. Little technical.
That has
Okay.
information.
Come again. Somebody is saying something.
Information between signal message.
Okay.
Signal.
In M of t, you are saying information is there, and in C of t, there is no information. It is only the carrier, right?
Yes,
Okay.
sir.
Okay. Any other? Any other? Any other difference between M of t and C of t? C of t, listen carefully. C of t is a single frequency. You said high frequency, right? So it is a single frequency or single tone high frequency signal, usually expressed in terms of cosine or sine. So AC cos 2 pi FCT, let us suppose. Now how to express M of t then? Can I write M of t as mathematically? M of t consists of many frequencies. Keep remember. These many frequencies are ranging from 0 to 4 kilohertz. So that is the reason we call it as band limited baseband signal. Band limited baseband signal. So therefore, my M of t is not of single frequency. It consists of many frequency components, whereas C of t is a single frequency, high frequency auxiliary sine wave, can be expressed as AC sine 2 pi FCT or AC cos 2 pi FCT. Fine. You have already completed the course on analog communications, right? So by this time, you know what is modulation. Can anyone tell me what is modulation? Modulation. What is modulation?
The changing of basic properties of message signal, carrier signal with respect to message signal. So.
Perfect. With respect to the amplitude of the message signal. Because message signal information is always contained in the amplitude, in terms of amplitude. So we are going to change the property of the carrier, whether it is the amplitude of the carrier or the frequency of the carrier or the phase of the carrier, in accordance with the variations of the amplitude of the baseband signal. So that is what we call it as modulation. So how many of you listen to radio? Radio. Any radio? Have you ever tuned to radio? No. You don't have radio. Hmm? Any radio? I think in the campus also we have one radio, right?
Yes, sir.
Which radio it is? The campus.
FM
90.4.
FM 90.4 hertz.
So 90.4 FM. Fine. So other than 90.4, can you name any radio channel?
93.5.
93.5 SFM, right? 93.5. Any other?
92.7.
92.7. What is the name of the channel?
EFM.
Which one?
EFM.
EFM. Okay. So I got three stations. One is 90.4 megahertz, one is 93.5 megahertz, and another one is 92.7 megahertz. Now, if you are tuning to these any one of the station in your radio, your mobile is having the radio, right? Or you can have a small digital radio. So can you identify the frequency range displayed there? What is the minimum and maximum frequency range of commercial FM broadcasting? Start point and end point on the tuning range of FM radio.
88 to 108 megahertz. 88 to 108 megahertz.
Perfect. So 88 to 108 megahertz is the commercial radio, FM radio broadcasting. Fine. Can anyone tell me what is the frequency range of AM broadcasting? AM.
535 to 1705 kilo.
535 to 1705. Okay. Kilohertz. Right. Or it is something close to 540 to 1650 kilohertz. Both are correct. Have you seen the AM radio?
Yes, sir. Akashvani.
AM radio. Akashvani. So it is like a big dabba, right? Huge box. All India Radio or Akashvani. Okay, fine. Now, can you tell me what is the difference between AM and FM? Which one is good?
FM, sir.
FM, sir.
Why? FM is good in what respect?
In terms of noise, sir.
Noise is good. Noise is high in FM?
Noise. No, sir. Low in FM, sir.
Noise is low in FM. Okay.
But
Noise is
but it will only for low range, sir. I mean, it is goes to only some particular range, sir.
so coverage area is less for FM. That is what you want to say, right?
Yes, sir.
Coverage area is
Yes.
less. Coverage area is more. So in FM, as you said, noise is very less. So the signal can be demodulated very easily. And the output of the receiver is very, very good or quality. Whereas in FM, the output of the FM radio is having a little bit of noise or sometimes more noise even. We can't even distinguish between what is the noise signal and what is the original signal. But the advantage here is for AM, it can propagate about say 100 or 20 kilometers. FM hardly 15-20 kilometers. Very rare 15-20 kilometers means. Now, for any radio receiver, the quality of the radio receiver or the performance of the radio receiver is dependent on exclusively the noise. To what extent noise can be removed during the demodulation process. In fact, you might have studied in your last unit of analog communication the term called SNR. So by definition, what is SNR?
Signal to noise ratio.
Signal to noise.
It is the signal power divided by noise power. Now you tell me, for a good receiver, whether my SNR should be very high or very low. For a good receiver, SNR should be very high or very low.
High, sir.
Very high, sir.
Very high. The reason is you should have a less amount of noise because the denominator should be less. Obviously, my SNR should be very high. Even my signal power at the output also should be high. Fine. So we have started with what is M of T and what is the frequency range of modulating signal, that is 0 to 4 kilohertz. And we defined carrier. Carrier is a single frequency, and M of T is consisting of many frequency components. And you have named that commercial radio broadcasting from 88 to 108 megahertz, and for AM radio broadcasting it is 535 kilohertz to 1705 kilohertz.